Let's dive right into this explainer. Today, we're unpacking what is absolutely the most profound structural transformation in software engineering since we swapped out physical punch cards for digital compilers. If you work anywhere in tech, you really need to hear this. We're talking about the explosive rise of autonomous AI agents and what that practically means for the traditional entry-level coder.
Think about this for a second. What exactly happens to an entire industry when its entry-level jobs just disappear overnight? It's a provocative question for sure, but it perfectly sets the stage for how these autonomous systems are completely rewiring the global tech labor market. Seriously, what happens when the very bottom rung of the career ladder just vanishes?
To really understand this paradigm shift, we're going to hit 6 key areas today: the collapse of the apprenticeship model, how AI agents actually work, the ruthless economics of synthetic labor, a massive looming crisis called the missing junior paradox, the hidden dangers in synthetic code, and finally, how we absolutely must redefine the entry-level engineer.
Okay, part 1. The apprenticeship model collapses. The end of the human junior.
For roughly 3 decades, the software industry basically ran on a subsidized apprenticeship model. You'd bring juniors in to do the repetitive grunt work, writing CRUD interfaces, localized bug fixes, basic unit tests. But the friction here is very real. For the first 6 to 9 months, human juniors actually cost a company more in senior mentorship time than they produce in actual business value. It's a period of massive negative ROI. We only tolerated eating that cost because that hands-on struggle was the exact engine that built our future senior architects.
Moving to part 2, how AI agents work, from autocomplete to autonomy.
Now, the primary limitation of early AI was that it just couldn't grasp an entire project all at once. But modern AI agents have completely overcome this. They use advanced retrieval-augmented generation, or RAG, paired with massive context windows of up to 1 to 2 million tokens. To put that into perspective, that means they can instantly ingest, query, and semantically understand an entire labyrinth of an enterprise codebase. They can identify exactly which nested dependencies need to be tweaked across millions of lines of code, all in one go.
And they pull off this autonomy through a deterministic workflow called the agentic loop. It's fascinating. An agent reads an issue, builds an execution plan, locates the files, writes the code, and then it actually runs the compiler. And if it throws an error, the agent just intercepts the output, reasons its way through the stack trace, and iterates. It continuously self-corrects. There's zero senior engineering hand-holding required here.
But it gets even crazier. The most advanced setups we're seeing don't even rely on a single agent. They use multi-agent systems. You've got distinct computational roles communicating at machine speed. Imagine an orchestrator acting as a product manager, a coding agent writing the syntax, an adversarial agent actively trying to break that code, and a security agent checking for vulnerabilities. It's literally an entire engineering department simulated in silicon, ideating and refactoring thousands of times before a human junior could even finish reading the Jira ticket.
Let's look at part 3, economics of synthetic labor, the ruthless math of automation.
The organizational drivers pushing this massive adoption really just come down to ruthless math. Just compare the two. A human junior takes months to onboard and demands a high salary, equity, and benefits. Meanwhile, an autonomous agent is onboarded in milliseconds and operates at fractions of a cent per task. For well-scoped tasks, agents are just exponentially faster and cheaper. In a macroeconomic environment that is obsessed with short-term efficiency, the immediate utility of the agent is completely wiping out the long-term investment of a human.
And this economic reality has birthed what's being called the lean unicorn. Driven by intense venture capital pressure for immediate profitability, especially now that the zero interest rate era is over, startups are heavily incentivized to keep their total headcount under 20 people. By deploying swarms of AI agents managed by just a handful of battle-hardened senior architects, they're achieving the output of a massive corporate department. They are completely redlining human juniors right out of the ecosystem.
So this completely changes the very shape of engineering organizations. We're moving from a traditional pyramid structure, where you have a ton of juniors supporting a few seniors at the top, to an emerging diamond shape. Think about a diamond. You have vanishing juniors at the bottom, a massive synthetic AI bulge doing all the execution in the middle, and a heavy concentration of senior orchestrators at the top. This forces a massive cognitive shift for senior engineers. They aren't really primary code writers anymore. They've become code reviewers and synthetic agent orchestrators.
Which brings us to part 4. The missing junior paradox, the looming talent pipeline collapse.
Now, for the massive narrative twist of this whole explainer, and a critical systemic risk that's being completely ignored. We call it the missing junior paradox. Look, software engineering at the senior architectural level is not something you master just by reading a textbook. It absolutely requires experiential learning. Juniors learn to design robust systems by making countless mistakes on small tasks and taking brutal feedback during code reviews. By automating that entire junior layer, the industry is creating a devastating tragedy of the commons.
Because here is the undeniable truth. An autonomous AI agent, no matter how incredibly advanced it gets, does not eventually grow up to be a human senior developer. It doesn't step into a leadership role or negotiate complex business goals with stakeholders. If every company rationally acts in its own self-interest by only hiring seniors and augmenting them with AI, then literally nobody is absorbing the cost of training the next generation. We're looking at projections showing an unprecedented shortage of experienced human architects in just 5 to 10 years.
Part 5. Security and Spaghetti Code. The hidden dangers of synthetic code. Without a robust pipeline of human oversight, relying entirely on probabilistic machine outputs introduces some severe existential blind spots into enterprise software. One of the biggest dangers is the illusion of competence. Because foundational models are trained to strictly follow corporate-style guides, their output looks absolutely flawless at a quick glance, but they lack a true grounded reality. For example, an agent might confidently implement a highly vulnerable MD5 encryption standard just because it popped up a lot in its scraped training data. When a human junior makes a mistake, it's usually loud and obvious, like a fatal application crash. But when AI makes an error, it is profoundly silent and mathematically complex. Beyond that, there are massive long-term systemic risks. Think about IP contamination. What happens when an agent accidentally regurgitates GPL-licensed open-source code right into your proprietary mission-critical application? That is an instant, massive legal liability. Then there's the spaghetti code horizon. Agents fundamentally struggle with holistic architectural vision. If you just keep bolting new, highly optimized logic onto existing structures for years on end, you will eventually degrade massive enterprise systems into unmaintainable architectural decay. And that leads us to our final section, Part 6, Redefining the Entry-Level Engineer, the Blueprint for the Future.
So how do we actually fix this? To survive this completely irreversible shift and maintain our system integrity, the industry has to fundamentally rewrite what it even means to be an entry-level engineer. The skills that used to guarantee you a job in tech are now completely commoditized by machine intelligence. Educational programs must pivot, and pivot hard. We have to move away from the obsolete junior mindset, focusing on raw syntax generation and imperative programming, and move entirely toward the new AI auditor role. This new role demands deep skills in declarative orchestration, rigorous systems architecture, probability theory, and adversarial fuzzing.
From day one on the job, the new junior workflow requires operating at a much higher level of abstraction. They have to precisely formulate architectural boundaries, constantly monitor agent telemetry, and be incredibly skeptical when reviewing massive synthetic pull requests. They'll be running advanced security audits and adversarially pushing back against AI hallucinations. It's essentially a new trial by auditing. Actually, scratch the term coder, they are AI wranglers. They are going to build their complex mental models by constantly analyzing, critiquing, and fixing the wide variety of attempts generated by these machines.
I want to leave you with one final thought to chew on. If machines are building the complex systems of today, who will possess the profound human intellect to design the systems of tomorrow? The traditional human junior coder writing basic boilerplate syntax might be economically obsolete, but the absolute necessity for profound human intellect, epistemological verification, and holistic system design, that is vastly more critical today than it has ever been before. We have to train humans to guide the machines, or we seriously risk losing the ability to understand our very own creations.